What's the difference between an equipment room and a telecommunications room? Let's find out. Hello everyone, Darren from i-LAN Technology. Welcome to i-LAN Technology's Introduction to Structured Cabling Principles and DINTEK Cabling Systems. This is part 3 of our 4-part webinar series to give everyone a bit more information about the cabling industry and how DINTEK products fit into it. In part 2 we looked at structured cabling subsystems starting with the entrance facilities. Today we'll be looking at the next subsystems in the line, equipment rooms and telecommunication rooms, and the cabling we use to connect these areas together. So, equipment rooms. In our previous webinars we went through the 6 separate subsystems under the ANSI TIA 568.1-D standard in a multi-floor building, which are number 1, the entrance facilities on the middle right hand side there, which we looked at in detail in our last webinar. Then clockwise we have our equipment room at number 2 and the telecommunications rooms at number 3, both of which we'll be looking at today. Between each floor is the backbone cabling shown at number 4 top right, followed by the horizontal cabling on each floor shown at the top left at number 5, and then finally at number 6 is the work area components. The equipment room is the next subsystem after the entrance facilities. Under the ANSI TIA 568.0-D standard covering generic cabling, the equipment room is our building distributor. It's the connection point between where the cabling comes in from other buildings and telco carriers and the cabling within the building itself. The equipment room is a centralised space within a building for telecommunications equipment that serves the occupants of the building. It's considered distinct from a telecommunications room because it serves a whole building or campus rather than a single floor, and because of the nature or complexity of the equipment it contains. Equipment rooms house the main and intermediate cross-connects for the backbone terminations. A cross-connect in cabling terms is a transition point where cables are terminated and then connected to other systems with patch leads or jumper cables. While considered distinct from telecommunications rooms, equipment rooms can sometimes also house cross-connects for horizontal cabling for a portion of the building, such as the floor thereon in some circumstances. Obviously, in a smaller home or office there wouldn't be a need to have a separate floor distributor. Typically, equipment rooms contain equipment like routers and switches, PBX systems, servers, and security systems like CCTV. Here's a pretty impressive equipment room in a large commercial building. You can see here lots of servers and blinking lights on the left, and patch panels and cables everywhere on the right. I'll include a link in the description below to an awesome tour of a school server room by YouTuber Jake Billing. There's various standards that apply to equipment rooms. They should be located in a centralised controlled environment. You really want to control who and what goes in or out of your equipment room, and that all environmental conditions are controlled. All doors should be outward opening with an automatic door closer fitted. They should be located where there's easy access to cabling pathways, and finished with a surface that's sealed to reduce dust using materials of an anti-static nature. Bare concrete floors aren't suitable. Consideration also needs to be given to the overall size of the room, with appropriate allowances for future expansion, and overall temperature for equipment to operate at maximum efficiency. There are other regulations like being fitted with smoke detectors, emergency lighting, fireproof doors, CO2 fire extinguishers and rodent proofing. The requirements that cover design and other functional requirements for equipment rooms are provided by the Pathways and Spaces standards such as ANSI TIA 569-A. Here's a couple of cables being installed in a brand new equipment room. Keeping track of each cable is important too. While some cablers like to tag as they go, that tends to be extremely time consuming, especially on larger jobs like this, and can be problematic because stuff always gets mixed up anyway. The easier way is with the use of an F-set. Here's a quick demonstration of an F-set, which is the easiest way to identify one cable in a bundle of dozens or even hundreds of cables. An F-set has 2 parts, a tone generator which puts an audible tone onto the cable, and a probe which picks up the tone at the other end. The probe makes a noise when it finds the cable. So out in the real world we could be dealing with wall sockets several rooms away or even on other floors, so it's impossible to manually track the cable from start to finish. So on a big job you'd get someone with a walkie-talkie plugging the tone generator into wall plates around the building one by one and buzzing the details back to the person at the patch panels as we go. So I've got 3 cables here and the tone generator connected to one. Is it this one? Nope. How about this one? Nope. What about this one? Bingo. Job done. There's other gadgets that can help with testing cables, like the simple continuity tester on the left here, which tests for stuff like open circuits and reverse polarity. That is, wires not punched down properly or that you might have got back to front. Then you get into expensive flute testers for testing throughput, crosstalk, noise and so on, but there are some relatively cheap gadgets on the market, like the POC Ethernet network analyzer on the right here, which is great for use on smaller jobs that don't require performance certification. This connects via Bluetooth to a smartphone, which can give you feedback about the Ethernet link, any faults, and can even check PoE voltage, VLAN and DHCP results. Getting the cables into an equipment room can be done in a number of ways, like overhead cable trays, with the use of ducting or conduits and cable trays, and raised floors are also common in equipment rooms. Note the suction cap handle needed to lift up the floor tiles, especially when it comes to pulling the first one up. And here's some typical equipment you might find in an equipment room, including wall cabinets, full-size rack cabinets, patch panels and jacks, and cable management panels. Management panels are more than just cosmetic too. Untidy cables can increase signal interference and crosstalk due to improper placement of data and power cables. Cables can also get damaged due to improper bends, movement or sharp edges, or just from people tripping over it or trampling it. I've seen cabinet doors that can't be closed due to untidy cabling, which leaves the cables susceptible to damage by people jamming the cables in the door. Cooling and airflow can also be restricted. You can probably imagine what's happening to the equipment underneath this mess, and maintenance and troubleshooting times are increased due to the difficulty of tracing cables, causing unnecessarily long outages when changing equipment over, just trying to sort through the spaghetti. It's amazing what can be achieved with a few cable ties and some cable management panels. Here's a before and after. They've used finger panels here on the front of the racks and finger panels installed vertically between the racks to route the cables and make everything a lot tidier. Another one, in this case they've routed the patch cables out to the sides into vertical finger management panels just like the last one. And one more, again using finger panels on the front of the racks and vertical ones between the racks to keep everything tidy and hidden. And then there's the other extreme. This looks awesome, but some cablers won't like it at all, and it also goes against standard TIA 568C.0, which states that cable stress, such as that caused by tension in suspended cable runs and tightly cinched bundles, should be minimised. Cable bindings, if used to tie multiple cables together, should be irregularly spaced and should be loosely fitted, that is, easily movable. A rule of thumb is you should be able to spin the cable tie around the bundle. These cable ties are clearly too tight. Many cablers don't like to use plastic cable ties at all and prefer cloth or Velcro straps, which are much kinder to the cable. But we've also got just way too many cable ties here as well, which might be fine if it's a permanent installation like this. This is for a data center, but just how permanent is any rack anyway? If any of those cables ever have to be replaced or new ones added in, you've got a huge pain on your hands. Unless you've got someone being paid by the hour to do it, what will happen is people will come along needing to do an add or move or an emergency repair. They won't have the time or the inclination to cut off and redo dozens of cable ties, so sooner or later it'll turn into a big mess. There's also evidence to suggest that running cables neatly beside each other can increase EMI and crosstalk, so a dog's breakfast with cables laid randomly all over the place may actually perform better than a neat cabling installation. There's even talk of bringing this into the cabling standards. Incidentally, a standard rack is 19 inches wide and about 6 feet high. Each shelf is called a rack unit, abbreviated as either RU or just U. So a 1U rack mountable device is 1 shelf high, 2U is 2 shelves high, and so on. And here's what passes as an equipment room small scale in a house. A full-size rack would obviously be overkill and completely unnecessary in a situation like this, so there's a variety of 19-inch shelves and wall cabinets available. This is a 2U shelf I installed in my previous home many years ago when I was running an online shop from there. Here we have a basic analog PABX system on the left, which had 2 PSTN lines. PSTN stands for Public Switch Telephone Network, also called POTS, plain old telephone system, and 2 VoIP lines coming out of a DINTEK 2710VN, I think it was. So we had 2 landlines and 2 VoIP lines to choose from at our handset. On the right is a patch panel with a switch underneath. Other people might have preferred a little wall-mounted cabinet here, but this was out of sight anyway, so I didn't think that was necessary. Notice those 4 white cables in the patch panel there. Those are the 4 lines coming out of the PABX system into the patch panel to go through to the phones at our desks. One very handy device DINTEK manufactured to make things easier for techies working on racks is the Tech Bench. The tech bench is basically a toolbox which folds out and clips to the front or back of a rack in seconds to create a sturdy work surface. Nice little touches like pins to hold a patch panel in place while you're working on it make everything much easier when working in what are usually quite confined spaces. Here's a short video showing the tech bench in action. On to telecommunications rooms. Our equipment room connects to our telecommunications rooms, which are basically more switches and patch panels, but on a smaller scale to service a single floor or area rather than a whole building. In this image, our telecommunications rooms are just wall cabinets. In a larger building, they'd be actual rooms or perhaps a full-size cupboard. Back to our ANSI TIA 568.0-D diagram, telecommunications rooms are our floor distributors, in between the building backbone cabling and the horizontal cabling for the floor they're on. In a multi-floor building, you'd usually find telecommunications rooms somewhere near the elevator on the other side of a door marked communications. Bearing in mind elevator shafts are not used for running communications cabling. They just usually, but not always, have a shaft in the same vicinity. As with equipment rooms, you want controlled access and environmental conditions. They should not be shared with other facilities like maintenance with sinks and mops and so on inside them. They should be located close to cabling pathways linking the horizontal cabling to the backbone cabling down to the equipment room. Consideration should also be given to the design and size of the room, to the housing of the telecommunications equipment, cable management, cable routing and cabling support. No sprinkler heads or water supplies should run through or over the room. EMI and RFI issues should also be considered when setting them up, and dual power outlets should be made available for the connection of active equipment. Cabinets are available in a few different shapes and sizes, but mostly you'll come across full rack height freestanding versions, all wall mounted types around 2U height. Ideally you want these lockable to keep meddlers out. You don't want call-outs caused by a staff member's partner fixing something that was never broken in the first place. Freestanding racks should be bolted to the floor with an aisle of at least 800mm wide front and rear. Wall-mounted cabinets are fine where the amount of equipment required wouldn't fill a full rack. They should be mounted at least 500mm off the floor, but the higher the better, and not installed in high traffic areas where people are likely to walk into them or smack their heads on them. They can end up with a fair bit of weight in them too, so hollow wall anchors on gyprock walls aren't suitable. In these cases, a backing board should be attached to the wall studs first, so the cabinet can be attached with decent coach bolts. Here's a fairly typical telecommunications room. Notice we don't have quite as much equipment here as we might have in an equipment room, so it looks a little sparse. In this case as well, we have a lockable room, so we don't need lockable cabinets for our equipment. And now a little bit about backbone cabling. Backbone cabling is the fourth subsystem under the ANSI TIA 568.1-D standard. It's the term used to describe the cabling that connects entrance facilities to the equipment room and the equipment room to the telecommunications rooms. Between buildings, we'd expect to see optic fibre for our backbone cabling. From the equipment room to the telecommunications rooms could be either optic fibre or UTP depending on the size of the building or the customer's requirements. Going back to the 568.0-D diagram, backbone cabling describes the cabling between campus distributor and building distributor, and also the cabling connecting our building distributor to our floor distributors. There's a bunch of standards that have to be adhered to, including that backbone cabling should use the star topology, there should be no more than 2 levels of cross connects, bridges and taps are not allowed, grounding should conform to the TIA 607 standard, and there's also requirements for maximum distances depending on the type of cable used. Here's a picture showing the cross connect between the backbone and horizontal cabling in a school. The top shelf is the fibre optic backbone cabling coming in from another building or perhaps from the equipment room. These and the horizontal cabling patch leads on the second row coming from the classrooms hook into the switches below to link everything together. DINTEK offer a range of backbone cabling products, including the LightLinks range of optic fibre products, which includes optic fibre cables, connectors, adapters and enclosures, and fibre patch cables including fan-out cable assemblies, cassette patch panels, adapter panels, as well as mechanical and epoxy tool kits. Backbone cable is usually out of sight and rarely thought about. Here's some optic fibre cable though that a backhoe managed to find. Telstra techies tell me that they find this sort of thing from time to time in their networks as well. A broken fibre link at the bottom of a hole in the middle of nowhere, surrounded by digger tracks but no digger to be seen. The reason for that is Telstra have a service guarantee to hospitals and large businesses and so on, and chopping through one of these cables often means taking out one of those links, which can add up to millions of dollars in downtime in a surprisingly short time. Many backhoe operators are aware of this and do a runner if they ever see blue cable come up in the dirt they're digging. So that ends our webinar at this point. In our next webinar we'll start looking at the final structured cabling subsystems, horizontal cable and work area components, and we'll also look at UTP cable basics and some history. For more information about DINTEK products, please visit our website at www.dintek.com.au, or you can send us an email at sales@dintek.com.au. Don't forget to like, subscribe and follow us on social media. You can find us on Facebook, YouTube and Twitter under the DINTEK Australia name. Thanks everyone, and bye for now.